Morning, guys. Today we will talk about chapter 12, the solution and mixtures, types of mixtures. So today we will actually explain what is the different type of mixtures. First of all, when we study the matters, we know that the matter is classified in two types, right? The matter could be a pure substances, right? First, when we study the matter, guys, we study the matter could be two types. It could be a mixture, or it could be a pure phase of matter. Anyone know what is the pure phase? What is the difference between pure and mixtures? Pure could be what? Could be element, could be
molecule.
Molecules could be compound. This is the pure phase of matter. Could be element, could be molecules, molecular compound, and so on. For the mixtures, we have two types of mixtures. Homogeneous, heterogeneous. Both of them identified in a specific way. The homogeneous is yet homogeneous.
We cannot
distinguish
between the particles inside.
Oh, okay. Or the definition as it's mentioned here as
in the book.
Is uniformly distributed. The particle of a solid is uniformly distributed between the solvent particle. Or it's uniformly attached and distributed beneath each other. So this is a homogeneous mixture. A great example of the homogeneous is the solution. And this is our main idea to explain in this lesson. Then a heterogeneous. The thing that characterizes the heterogeneous, you could actually differentiate or distinguish between the component of the solvent or of the two mixtures. You know the component by your naked eye. You don't need a specific tool to see the molecules, okay? And for example, the salad. Salad is a type of heterogeneous molecule. A group of nuts. A group of nuts, like fruit salad, is a heterogeneous. I could see the component of that. In heterogeneous, we will study two types, suspension and colloid. We will understand, identify each one of them, give some example of how to, and what is the difference between the three types of mixtures here, solution, suspension, and colloid. The first thing, let's get back to the here. First, we have, as I said, the substances as the solutions could be soluble and insoluble. The soluble substances is capable to dissolve in a solvent. Insoluble substances not capable to dissolve. Could anyone give me an example of soluble substances or insoluble substances? For example, in water. Anas.
Salt can be dissolved in water.
Yeah, so the salt or ionic compound, most of the ionic compounds are soluble. Right. Insoluble.
Gold.
Gold, the metal. When we put some metal in water, it will not dissolve. Or sand. Or what? Oil. Oil is not dissolved, right? Because we have rules in solubility. It's called light dissolves light. Does this mean polar compound will dissolve in polar compound, non-polar compound will dissolve in non-polar compound? Because before we come to this part, here for example, is the solution is a form of homogeneous mixtures or heterogeneous. For example, if I have a salt and I put a fresh water, some salt in a fresh water and they stir it, so could I actually see the particle of salt?
No, it's homogeneous.
It's homogeneous because the particle is actually distributed uniformly between the solvent particles, and I could not actually see it by my naked eye. We are talking about the atomic scale. So the first idea that I want you to understand it is a solution is a homogeneous mixture. So all solutions is a homogeneous mixture. When we heard that a solution is a homogeneous mixture of two or more substances in a single phase. What means in a single phase? It means that the final product could be a gas or solid or liquid. Because this is a misconception for some of the students. When they heard the word solutions, it means that the first one is a liquid substance. But the solution could exist in the three types of matter, or the three phases: solid, gas, and liquid. For example, the atmosphere around us is a form of solutions, homogeneous mixtures. Why? Could you identify the nitrogen atoms or nitrogen gas around it, or the oxygen gas or carbon dioxide? No, it's a homogeneous mixtures that uniformly distributed between each other. For a liquid one, for example, salt and water, table salt, sodium chloride. When we dissolve it in water and distribute it, it gives us a homogeneous mixture of salty water. The particle of the salt disappear between the water, and we could not identify it as it's a homogeneous mixture. And finally, is a solid, is an alloys. All the alloys is type of a solution, solid solution. When we have two metals, we melted them and we put them together, then left them to solidify. It will gives us a homogeneous mixture, a solution of two solids. Remember the most important rule in solutions, that do they form by a chemical change or solubility, just a physical change? Yeah. Physically change. So remember, they are not chemically attached to form any kind of solution. Solutions is formed because of a physical change. Solubility is a physical change, not a chemical change, because there is no bond formed. Now we have to identify the component of the solution. The solution is composed of a solvent and solute. So let's explain how this happened in the board here. So the first homogeneous mixture is solution. Any solution, guys, is actually composed of two parts, right?
Yes.
Solvent
Solute.
and solid. Anyone know what is the difference between them? Anyone else? Sadia and Anas. Yes.
The substance involved in the solution is called the solid.
Exactly. Some substances that dissolve in the solutions, this one is called the solute. And the solvent is the medium that dissociate the substance that put it inside. And normally we could actually distinguish between them according to the amount. Normally the solvent comes with the big amount, the solid comes with the small amount. Okay? But this is not a rule, because sometimes you could find it's 50-50%. Okay? But normally the solvent comes with a bigger amount. Is there another way we could determine? Yes. If we have an example of a solution of NaCl, ionic compound, that dissolve in water, okay, this is will form free ions of Na positive plus Cl negative. So how this happen? If we draw a beaker of water, anyone structure the structure of water molecules. What is the structure? What is the chemical formula for water? Chemical formula for water?
H2.
H2O. We know that the oxygen is covalently bonded with two hydrogen atoms with an angle 105 approximately. So if we have a 3D shape for the molecules, this is how the oxygen have, and this is how the two hydrogen attached to it. Okay? And we know that a water is a polar or a non-polar compound. Polar. This is mean that there is a partial negative charge and the oxygen atom, because it's a high electronegativity, and there is a partial positive charge appear on the hydrogen because it's the lower electronegativity. See what happened during that dissolve or dissociation between when we dissolve the sodium accelerate to positive ion and Cl negative. In the solubility, we know that the solvent particle will surround each ion. So if we represent these two ions, here we represent, for example, the chlorine with the negative. This is the ion of chlorine. And with the green part is the atoms of. We know that according to electrostatic, like the similar charge attracted to each other or repelled from each other. Repelled, and opposite charge attract to each other. So the water molecule will surround each ion from each side. For example, here the water molecules will surround the chlorine ion from the side of oxygen or the side of hydrogen. From the side of hydrogen, because it's attracted to the opposite charge. So we will find the water molecule like this, surround the chlorine atom from the hydrogen side. And this is how the dissociation happens or the solvation. But in the case of the sodium, they were surrounded from the oxygen side, right? Why? Because the oxygen is negative, sodium ion is positively charged, so it will attract to the opposite charge, and this is the rest of the molecules. So this is simply how the dissociation happens, or the dissolving of a solid beneath a solvent particle. Remember, we take in the solution, it's homogeneous because we talk about the small scales, we talk about ion scales, atom scales, or small molecule scale. I want you to remember this with an example of ionic compound. We will take as the salt of a non-polar compound and a polar compound. Let's take an example of a polar and non-polar compound. Before we take this, let's get to the PowerPoint to finish the solubility. As you see here, could you determine which is one is the solvent, which is one is the solute here? For example, here we have ethanol molecules dissolved in water. The green one is the ethanol, right? And the red blue one is the water. So which is one is the solvent, which is one is the solute?
Water is the solvent.
Yeah.
And we have the
Ethanol?
which means the solute.
Exactly. Here, for example, we have gold and silver. It's an alloy. The gold is moon color with the big amount, so it's considered as a solvent, and silver considered as. Now, you have to differentiate between the solubility of the